All right, guys, so we're going to start by defining some things for section 5.2. So make sure all of these definitions are written down in your notebooks, hopefully with paper and pencil. So the first thing is what an exterior angle is. So we're going to be referring from now on to triangles. And inside of triangles are the interior angles. And then outside of the triangle is actually the exterior angle. So if we extended, you can see we extended past C to point D. And this pink angle right here, we're considering that our exterior angle. And all triangles have 3 exterior angles, right? So you can extend the sides and see what the exterior angle is. We have the adjacent interior angle, which is this green angle, and it is adjacent meaning next to. And then we have these remote interior angles. So they're called the remote interior angles because they are not touching that exterior angle. So these are the 2 angles, again, that are on the inside that are not touching this pink exterior angle. So those are my remote angles. The definition of exterior angle is an angle adjacent or next to and supplementary to an interior angle in the triangle. So you can see our 180 degrees, bam, right there. Next we have theorem 30. So the measure of one of the exterior angle that you're looking at, it's greater than the measure of either remote angle. So keep in mind that the remote angle are those orange angles that's not touching that exterior angle. So I'm just going to make up a couple examples for you guys so you can see this. I'm going to pick easy numbers. So let's say this is 50 and this is 30. Okay, so those are my remote angles. It's not the adjacent angle that's touching that exterior angle. So if that's 50 and that's 30, because we know a triangle adds up to 180, this angle right here would have to be 100, making this angle, I think I used pink, making this angle 80 degrees. And you can see that 80 is larger than both of my remote interior angles. That 80 degrees is larger or greater than the measure of either of those remote interior angles. Now I just made the 50 and the 30 up, so we can try something else. Let's make one of them like obtuse. So we'll do 50 and 100, right? So let's pick up these obscure choices. So again, if this is 50 and this is 100, a triangle adds up to 180. This would be 30 degrees. Because this is supplementary right here, this has to be 150 degrees. Oh, look, it's bigger than 50 and it's bigger than 100. Okay, so that's what that theorem states, is just that this exterior angle is going to be bigger than either of these 2 remote angles. Okay. Now we're going to talk about how to prove lines parallel. How to prove lines parallel. Okay, so let's take a look at these 3 lines. So I don't know if you guys can see this. I have a blue line, a purple line, and a green line. Right now they're stacked on top of each other. If I could click on a line, and I did, I got the green one, and I can open it up. So I'm opening it up, okay? When I'm opening it, I'm creating, do you see this? I'm creating what's called an angle. So that's how I'm creating my angle. So let's say I opened the green one up and I opened it up 70 degrees. So 70 degrees from my blue line, my green line, I opened up right here, 70 degrees. If I wanted my purple line, I don't know if I can hit it. If I wanted my purple line, I did it, to be parallel to the green line. I want you to think about this. I would also have to open this purple line. Is that parallel? No. Is that parallel? No. Oh. I would also have to open the purple line 70 degrees from that blue line in order for these to be parallel. So you can take a look at this, and this is actually our first theorem. Okay, so you can see there are no longer parallel tick marks. Oh, look, That's crazy. How do we know that these are parallel? I don't see the tick marks. Well, we have theorem 31. I was going to say 21. 31. Theorem 31. Here are all of the different ways that we can prove lines are parallel. So it starts off the same way for each of these. It says, if two lines are cut by a transversal, so remember we're bringing in 3 lines in this section. So if we have 2 lines that are cut by a transversal, first one, theorem 31, and alternate interior angles are congruent, and that's what you'll see in my picture above. Alternate interior angles are congruent, then the lines are parallel. Okay, that was our first one. Next one, if 2 lines are cut by a transversal and alternate exterior angles are congruent, right here, then the lines are parallel. Okay, so you can see where I'm going with this. I was just lazy to type everything out. If 2 lines are cut by a transversal, I'm doing green now. If 2 lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Next one. If 2 lines are cut by a transversal and interior angles on the same side of the transversal are supplementary, then the lines are parallel. And lastly, I'm running out of colors. If 2 lines are cut by a transversal and exterior angles on the same side of the transversal are supplementary, then the lines are parallel. Okay, so just to draw some examples of this, now you no longer need, when you see lines and you're like, are these parallel? As of right now, your answer should be no. No, those are not parallel. I do not see, parallel marks on them, and I don't see any angle measures. So then it's like, well, okay, what do I need? Let's say, for example, this is 100 and this is 80. Okay. Now, again, you can use your theorems. This would be the orange theorem. So if exterior angles on the same side of the transversal are supplementary, then the lines are parallel. So you can see here, you can use that theorem and you're done. So if somebody said, hey, are those lines parallel? How do you know? You could say, yeah, if 2 lines are cut by transversal and same side exterior angles, right, same side of the transversal, exterior angles are supplementary, I know the lines are parallel. It's one of the theorems. If you forget and you're like, oh boy, I completely forget, and you happen to use angles that you can always use vertical angles, and you can always use your supplementary linear pair windshield wiper angles. We know this is 100. So then it's like, well, I know because this angle is 100 and I open this one 100, and those are called corresponding angles. So you would use this theorem right here. Okay, so if 2 lines are cut by transversal and corresponding angles are congruent, then the lines have to be parallel. So there's a multitude of these that you can use for each of these proofs, whichever one your gut kind of goes to. But by looking at lines now, you are now able to tell by angle measures if the lines are parallel. You no longer need those little fish gill parallel marks. We're jumping straight into, we're looking at pictures. Okay, so again, if you see some pictures, even without angle measures, even if you just see some tick marks, let's say I put a tick mark here and a tick mark here. This is, let's see, alternate interior, theorem 31, or theorem 1 that you see right here, this pink one, right there. So this is if 2 lines are cut by transversal, and you see that, you see 2 lines cut by this transversal right here, and alternate interior, there's my Zorro angles, bam, 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 and alternate interior angles are congruent, right here, then the lines have to be parallel. So I can say because those 2 angles are congruent to each other, A is parallel to B. Okay, so I know those are parallel because alternate interior angles are congruent. So again, this is ways to prove lines are parallel. Last theorem, I know this is a lot of theorems for today. Again, very obvious. If two lines are perpendicular to a third line, okay, then they're parallel. So if the blue line is perpendicular, okay, you can see this right here. The blue line is perpendicular to the purple line. And the green line, here's my green one, is also perpendicular to the purple one. Then the blue and the green have to be parallel. There's no way around it. So if you happen to see a drawing like this and you see that this is 90 and this is 90, this is very obvious, guys. We just went over this up here. Okay, you can see this with corresponding. There you go. Number 3. Those two angles right there are corresponding. Okay, so if corresponding angles are congruent, lines have to be parallel. So we know this. But again, if two lines are perpendicular to a third line, then they are parallel. Okay, so we know that those, again, A and B have to be parallel because we have both of them perpendicular to the same line. Okay, so again, this is section 5.2, learning all about exterior angles of a triangle, remote interior angles of a triangle, the adjacent interior angles, how to prove lines are parallel. Again, you can prove lines parallel just by looking at the angle measures now without the fish scales. And then also you're looking at two perpendicular lines to a third line, then those two have to be parallel.